Okay guys, I have my 3D printer running in the background, and so you're going to have to put up with that noise, unfortunately. But I was doing something, just bored at the same time after I had started that print, and I decided to try something, and it turns out it worked, and I have a second unit to try it on, and so I thought it might be cool to share. So what this is, I have a few of these batteries. Eco USBCell. I forget, there was another brand name that was like a parent over these. These were a very early USB rechargeable AA and AAA company. They're defunct now. I've had these a long time. These have a manufacture date of 2015. And they sat in a drawer for a really long time, and I recently rediscovered them, and a couple of them still work, and a couple of them don't. So the way these are, the AA size just has a full USB-A port on the front for recharging, and they have repurposed the center, so you probably can't, I'm not going to mess this one up because this one works, but if you look down in there, I don't think that's going to show up on camera. Can I try and get close? I don't know if it's going to work. Hold on. Try to focus. Focus? No? Oh, that's better. So if you look down in there, it's still not very focused. But what they've got is a center pad where the two data pins should be, and they're just tied common. And that's actually being used as the output on this. So the regular USB power pins recharge it, and then the ground and the center become the output. And in the cap, there's just contacts in there just to connect. There's a little magnet on the end to hold the cap on, and then there's contacts in there that just connect the output to the tip. And so when you plug this into a USB port, even, hold on, I can show you that. Yes, right here, this is powered up. So if you plug it into a USB port, does that show on camera? Change the focus. There's a little, shield the lamp, there's a red LED, and that turns green when it's done charging. So you get a little charge indicator on each battery. And you can use any USB, well, almost any USB-A port. There's a caveat that I'll share in just a second that you'll see. That applies to the AAA. So that's the AA cell, and this thing still works, and I'm really pleased that I found these in a drawer somewhere because I had been looking for them. I liked having them. So the AAA size battery has to be different because it's not so fat. So it's actually got this half of a USB port. So you've got, and this is the caveat, so this won't work with just any USB port for recharging. It has to be a USB port where there's the metal outside of the port is grounded, shared with ground, because it's using the sheath only as the ground. But you can see if I plug this in, let me try and show you so you can see this, it only fits in to half that USB port, so half of it just kind of stays open, and you get a charge indicator with this as well. But this thing, this and the other, I had two of the AAAs, actually three of the AAAs, one's already totally destroyed and was useless, that they charge up. This says charged really rapidly, and then it takes no time at all for it to stop outputting. The batteries, the internal cell is not actually holding anything. And this is doing the same trick. It's got the shell is the ground, USB plus power, lost my focus, USB plus power on that side, and then where the two data pins would have been, it's got just one larger pad that is the output again, and the cap's just designed a little different from the AA to carry those over. And again, a little magnet holds the cap in place. You can actually even throw the cap on the back with the magnet while it's charging if you want to. But it's not super strong, so it's not, I guess it's not that bad. But it's not, if you were to bump it, it's not too hard to dislodge. So my thought that I had was, I wonder if, so there's obviously circuitry in here for recharging a lithium cell, and for stepping down a lithium output to 1.5 volts, as well as overcharge and over discharge protection. This one, the writing on it claims this is 450 milliamp hours for the AAA cell, and the AA cell, let me pull that back out. What does it say? This says 1040 milliamp hours. So they're not very energy dense compared to like a standard alkaline, or even a lot of nickel metal hydrides would have more capacity than that. But they do recharge super easy, and it's a really convenient form factor. This company's out of business, but there are a few other companies that exist now that make similar things. It's real popular now, instead of having a fully removable cap, to see ones that have like a micro USB or a USB-C, like just on the side of the cell, and you just plug in a cable to recharge them now, because this connector frankly wastes a lot of space that's valuable in something so small. So what I did, I just took apart one of these AAAs. So let me refocus here, because I'm willing to bet I'm out. So I just took apart one of these AAAs, and I was very careful about getting into it, and I was able to take out the old LiPo cell and expose the two contacts that go. So the first one of these that I tried taking apart, I mangled this. I tried applying heat to this plastic. Everything's potted in this plastic on the top. I tried applying heat. I tried cutting at it with nippers and stuff, and I just mangled all the stuff on the circuit board inside. It's very tiny stuff. It's very dense actually under there, and as soon as you try to pull on this plastic, it all just rips components and was useless. So this one I cut into it with a Dremel so I could get into the back of it, and was able to expose these two these are the two battery contacts. Positive is this one was wrapped in Kapton tape, and then the negative right here, which is barely sticking out still. But I tested it. I hooked up my bench power supply to these, and I got the 1.5 volts out, and I plugged it into a USB port, and I got 4.15 charging voltage on these. So it still works. I'm going to be able to solder up. I've got pull this out. I've got a selection of old cells here that whenever I recover them from something, before throwing something out, I take the cells out, tape up their contacts, and I've got a bunch of, you see that came out of an old Garmin. This is from an old Motorola. A bunch of these from different stuff. This came out of a Samsung phone. A couple of these came out of Bluetooth keyboards that had stopped working. So there's a bunch of these. I got a bunch of these just out of random stuff. Some of these have come out of vapor producing devices. A couple of these. Oh, this one's from a vapor device. It actually looks like a capacitor, but that's a LiPo, and just in a weird form factor. So some of these came out of tablets. I think this was a cheap Kindle tablet a long time ago. But anyway, I always hold on to these things because having a selection of weird size cells, you never know when it'll be handy. So anyway, so I'm going to show you how I got this one out, and it still works. And I'm going to try to replicate that result on this one. It's super delicate. It may not work, but I'm going to do my best. So first I'm going to tear off this. This is just like a shrink wrap on it. We're going to be cutting into this, so if you hold this one up for comparison, basically the entirety of this can below where this plastic chunk ends, that's all a LiPo pouch that's in there. So you want to do this when it's totally dead and has no energy. But this is all like a little skinny LiPo pouch that's inside of there. And so we're going to take a Dremel with a cutoff wheel, and we are going to very, very carefully cut down a line so that we can basically peel this can open and gently get the can off without damaging any of the electronics that are inside the plastic. We're almost for sure gonna cut into the LiPo pouch during that process, so yeah, if it's got energy in it, you don't want that. So this is going to be loud probably while I'm dremeling. I'm going to try to keep it up here in the camera. I'm going to hold it with a pair of pliers here, and that's just going to, this might get warm with cutting, and also it'll kind of protect me from going too far towards that plastic at first here. What I'm going to do is first I'm going to cut off the flat end of the can, and then I'm going to make a slit going most of the way up. And then we'll use pliers to kind of peel that. So this Dremel is probably going to be real loud. I will mute this, and I'll mute this and fast forward, and we can talk when I get done with this step. So there you can see I cut the to the very bottom of the can off. You can see how little of a sliver I took, and it took the bottom of the pouch with it. You can see some of the electrolyte floating up there. Hold on, how do I'm gonna try to zoom this. Hold on. Yeah. Oh, that's gonna focus. I don't know how well that's gonna show up on camera, but you can see the layers of the LiPo pouch in there, all spun around. All right, zoom back out. Oh, there's the zoom controls. I'm doing pinching. All right, so loud again. I will reduce the volume and probably fast forward this. We're gonna make a slit up here. Ooh, that's really warm. We're gonna give that a second. I did look at the pouch I took out of the first one I did. It was I still had enough of it to read, and it was an EVE brand cell, and I believe it was a 96-300 was the size dimension given. It's cooled down enough now. So what I'm going to try to do, we're going to try to just get in there through that. I'm just taking a couple of these pliers here and just trying to get a grip on it. It's rather difficult until you get that LiPo cell kind of out of your way. Let me grab, and I have, oh, there we are. Let's grab something that's a little stronger. So if we can just kind of peel this back, there we are. Oh, perfect. So you've got, these are the outer layers of the LiPo cell here. So we can kind of keep those intact away from the wall, and then we can adjust our grip. Let's just see if we can get this whole thing out. So you can see already this capped on tape here is covering the positive lead, positive of the battery. So we don't want to accidentally tug on that and sever anything. because we want it to stay. If we rip it out of the plastic on the, if we rip it out of that plastic on the end, I don't think we'd be able to find a way to connect connection point without destroying the circuit. As soon as I tried to do almost anything to that plastic on the first one, it went poorly. It took components with it right away, so it's very delicate under there. So if we, so there's a little bit, this is kind of looks like, I thought it was glue at first on the other one. This is just flashing from this being molded in. Some of it flashes down. So we can kind of trim that up a little bit. Let's see if we can see. I'm assuming this is going to be the same type of LiPo pouch. See a serial number? There it is. EVE 96300 CH 0.81 watt hours, I think is what that says. So EVE brand. Is that showing up? That was glare. Yeah, there it is. So we need to get the rest of this metal off. I guess we technically don't need to, but I want it off. I don't want to leave anything sharp on accident on here. What I'm going to do with these is hook up a very small LiPo cell in place of this one, and be able to add this into a couple devices that I want to run at 1.5 volts, and don't want to have to keep replacing cells. So I think if I put like a little connector on it for the cell, then I can plug in any size LiPo and be able to have it basically be like a really massive AA battery equivalent, or I can make it really compact or whatever you want for stuff that I don't want to keep buying batteries for. Specifically, right now the first thing I want to use is this. So this takes a single 1.5 volt button cell. This is a really cheap, like Amazon generic caliper. It works fine. Good enough for me, just doing like using to measure stuff for like 3D modeling and stuff. But buying LR44s all the time is just annoying, and I always forget to pick one up when I'm at the store, and so this thing has sat for a long while now, not used. So my plan is I'll be able to use this very tiny converter, 1.5 volt regulator, and probably like put some double-sided tape right here, and I can either just plug in a power supply when I need it. I could even plug it into the bench power supply real easy, and I'm just going to solder its 1.5 volt output onto these battery contacts, and never have to worry about having a tiny little button cell again for that. So let's put that aside. Let's keep going on this project. So let's see. I was a little too rough with the last one, and I made the negative contact very short on accident. So let me grab a knife, and we'll see if we can get this to come apart more cleanly. I'm going to try to be real careful here. So we've got that positive lead going right there, and we know from the other one that the negative lead's basically on the opposite side from that. And so I just want to try and be as gentle as I can. I'm just cutting at the end of where the flashing starts. And we're just going to try to be real gentle. Just kind of score it and then rip it so that it if we're lucky, this will work. This in here, tug on that. Oh, nice. That pulled away nice. Alright, so where, I need to try and see in here where exactly that goes. We've got this positive disconnected already. There's like a shrink wrap over this. Hold on. Let's put a nick in that. So we can rip that off. So there's like a shrink wrap outer plastic that was around the battery. That makes sense, insulating it from the overall can. So we've got, there's our positive lead, separated and safe. Let's be gentle in here, find our other lead. There we are. So the other one, whoop. So there's the other lead, just leading right into the end of the cell. So we are going to be careful, pull this open. Probably should have worn gloves for this, but it was very spur of the moment. So we're just going to make do. Trying to peel this off gently so we don't rip that contact problematically short. Okay, so there's the contact going into the end. I'm going to use my knife here. Try to cut the LiPo free. So here's our rip that. There's our LiPo guts, most of them. So if you didn't know how a LiPo cell cylinder is built, it's many layers of alternating anodes and cathodes with separator in there, and you can smell, there's a very distinct smell to the electrolyte when you pop one of these. So it's a very unique smell. It's almost like a nail polish remover, but slightly different. It's I don't know, similar enough. Obviously, don't ever handle a torn or open LiPo if it's got any energy in it at all, or if you're unsure of if it's got energy at all, because you can, by handling that especially, you can kind of squeeze the layers together and cause them to release energy, and they'll heat up super quick on your fingers. So even if it's just sitting there doing nothing, you may not realize how much energy is still hiding inside there. So we're going to take this, I'm going to try to be very gentle here, and I'm just trying to pull everything away from that contact lead. Once I solder on some like JST plugs or something for the battery and the input output, then I will pot these into like hot glue or something, so that they are not so fragile. But we're gonna go in here, I'm gonna cut this pouch shell away. See if we can get in here carefully. I'm sure there's people out there that are yelling some easier way to try and do this, but actually there's probably not. Probably very few people have ever bothered to do something like this. But I am extremely cheap. I hate spending money whenever I don't have to. If it's something I can fix, or something I can make, or something I can recycle, I would much rather do that. So I know some people will say, hey, you can get a 1.5 volt regulator for pennies a piece. Or you can get, this is actually a switching power supply, because it's got a little, I know from the first one that I demolished, it's got a little control microchip and a little inductor and everything in there, plus the charge circuitry. So this is a 1.5 volt switching regulator and LiPo charger circuit in this little thing. And if I was going to order that off like Amazon or AliExpress or something, I'm probably going to spend $1 or $2 per unit and shipping. And they're probably not going to be this small. And this was a major company that was, I don't know why they went out of business, but I'm willing to bet it was just a little too early for this style of battery to be popular. And they weren't cheap. I bought these at the time. I bought a 4-pack of the AA and a 4-pack of the AAA. And I want to say it was 20 or 25 bucks each for the 4-packs. Something like that. But I used them in like all my remote controls and stuff for a long while, and was very happy to have easy to recharge batteries that had super low self-discharge. I don't know what the actual like quiescent current is on this, but they did pretty good. So I can see I've got some of that contact exposed now. I've got more on this I need to clean off, but we're getting to the good part. It's just hard to pull on stuff without, you know, you're afraid of ripping it out of that plastic base and ruining it. So I've got this. I'll just try to trim some of this back so I've got it exposed okay. There, can you see that okay? I don't know. See if I can. Is that going to focus? Not quite. Oh, that's better. So you can see I've got, there's like all this sticky stuff from where it was inside the LiPo cell, but I've got a bit of it exposed. Enough of it, I'm sure. And so now let's see if this one works. See if I accidentally broke anything in that process. So, step first, we need to cut into this capped on tape and just peel this away to expose this lead now, which is gratefully easier to get off than that other one is. Get this open. Sorry, let me be off camera for a second so I can try to stare at this little tiny piece and get it off without ripping the parts we care about. Yeah, I definitely wish I had worn gloves before doing this so that I didn't have all that LiPo gunk all over me, but I think we'll be okay. Okay, perfect. So now we got this. Whoop. There. Now we've got that lead exposed also. So what I'm going to do, first test, I will take my meter. My wires are all crisscrossed now. I wasn't planning on recording anything today, so I'm sorry. I'm sorry for the 3D printer in the background and all the nonsense, but let's see. Oh, I'm way out of focus. I'm sorry. How long has that been like that? Alright, so there's that. I'm just going to clip on some alligator clips here onto my multimeter so we can see this. So I'm clipping it on to where the battery ought to go. And then, if we very carefully bring this over so we can plug it in. How do we want to do this? This plugs in. So we should see this put out 4.2 volts to charge the battery. And there you can see it's putting out 4.15. Green light is on because obviously it thinks it's already at that full voltage immediately. So that works. So we successfully did this without breaking it. I'm thrilled. The next thing I'm going to do, I'm going to turn on my bench power supply. I don't need these alligator clips anymore. Put these aside. Let's take these. So these clips are my bench power supply. We've got negative there. We've got positive there. And I've got my bench power supply set to 3.5 volts, which is in the range of a LiPo. And we can see, I'm going to put negative to the outer sheath. What's going on here? Put negative to the outer sheath, positive to what would be the middle pin, and you can see we've got 1.5 volts. If I can hold it steady, 1.5 volts, bang on. So it's working 100%. So now, turn off that power supply. So now I've got two of these tiny 1.5 volt switching buck regulators with LiPo charging integrated into them. I will put a JST plug connector onto them for one of them. I'm probably going to just put a LiPo like permanently on, just a new LiPo, a chunkier one than they had before, and have it be dedicated to the caliper here. The other one probably will just put JST plugs for the battery and the input-output so that I can find a use for it later easily. But I think this is super cool. So maybe not all LiPo AA's or AAA's would work somehow for this, to take them apart and use their brains in other stuff. But I'm super excited to see this work. These things are micro tiny. They're super small. That's what micro tiny means. I'm repeating myself. But super small, super light, and because I got them from a major corporation that was selling their wares in national chains like Walmart and Best Buy, I'm reasonably confident that they are very safe designs. It's not like a random Chinese knockoff of a regulator using questionable parts. They are. I'm not saying that I know for a fact what kind of stuff they use. I'm just saying, I'm assuming because they were in major big stores, national chain stores in the USA, and I assume in elsewhere as well. But I'm assuming they must be at least pretty safe. Obviously, please don't go in the comments. I know bad stuff's out in stores here and there and everywhere. So yeah, I know bad stuff happens. And for all I know, they went out of business for some secret design flaw that I don't know about. So I'm just saying, sometimes you get some extra sketchy stuff off like AliExpress or whatever, and you don't know it till it's too late. And I'm just assuming these are going to be a little bit less sketchy than that. So, yeah. If you guys want a follow-up of showing everything hooked up on one of these and potted into something, I've got really small, like, probably like one of these. Oh, if I can get the bag open, hold on. I've got these really tiny little plastic project boxes. Could maybe do one of these, or maybe I just 3D print something extra smaller than this. See, I could fit a LiPo and this whole thing in there and just have wires running out the side. Yeah, I know it's not super practical, and I know it might be smarter to just get like a AA cell holder to just hook up to it. I know there's lots of other ways to accomplish this task without so much effort, but for me, the effort of tinkering with this stuff is what's fun. And finding a way to reuse something that 20 minutes ago I thought was just going to have to go in the garbage bin, I love that. I just enjoy that a lot. So, hope you found this interesting. I'm very pleasantly surprised. And I'll catch you guys later. Bye.